Integrating Stoicism into your personality. Welcome back, dear friends. We've committed to living a Stoic life. But here's the challenge. Are we following Stoicism authentically, or are we just mimicking behaviors that don't fit our nature? William B. Irvine reminds us to adjust Stoic principles to our personality, while Naval Ravikant insists that authenticity is the ultimate escape from competition. Stoicism, like machine learning, requires calibration. In ML, this calibration happens through hyperparameters like learning rate, how big a step the model takes to improve, and epochs, how many times it reviews its data. In life, our learning rate is the intensity of experiences that help us grow, and our epochs are the reflections we gain across repeated life events. Hyperparameters are set before the model engages in its training loop. Likewise, before we try to live stoically, we should ask, what rhythm of discipline suits my personality and values? Search strategies in life. ML has different strategies for finding the best hyperparameters. These map beautifully onto Stoic experimentation. Random search implies trying random combinations. In life, this is like experimenting with pausing before speaking, or learning that not every battle deserves a reaction. Grid search tries every option. The grid search can resemble our experimentation with detachment, just like requesting a day off when we try to experiment with a work-life balance after years of only prioritizing our career. Bayesian optimization makes smarter guesses based on experience. This is like reflecting on what made us reactive and choosing differently next time. Optuna refines Bayesian with science. In life, it's like Nassim Nicholas Taleb's via negativa, removing harm before adding good, befriending risk, and building anti-fragility. Avoiding misconceptions. A common trap is to see Stoicism as numbness or passivity. Such vision resembles a class imbalance in machine learning. In ML, class imbalance happens when one category dominates, making it harder to learn from the minority class. In life, if we suppress all emotions, we fail to distinguish between destructive emotions, and eupathei, healthy emotions. So how do we restore balance? Strategies against class. Imbalance 1. Data collection. Read Stoic texts, both classical and modern, but also collect inner data. Notice your triggers, patterns, and victories. 2. Regularization. Prevents models from being too flexible, overfitting, or too rigid, underfitting. In life, don't live without values, overfit, but don't cling rigidly to things you can't control, underfit. 3. Resampling or balancing the data through. Random oversampling, repeating data to balance classes. In life, over-practicing detachment until it becomes numbness. Random undersampling, discarding data from the majority. In life, tempering hope until you lose motivation, instead of practicing Epictetus's dichotomy of control by taking responsibility for our choices, not giving up. Smote, creating synthetic examples. In life, reframing situations to see alternative lessons. Tomek links, removing overlaps between classes. In life, realizing we're attached not to roles, but to our deeper mission. ADASYN, generating examples near misclassifications. In life, growing from mistakes, recognizing the role of others, and cultivating duty which could prevent us from falling into the trap of individualism. As Marcus Aurelius said, what is not good for the beehive cannot be good for the bee. 4th, algorithm level adjustments. Instead of changing data, we adjust the algorithm. Algorithm level strategies are recommended when challenged with data sets that, or too limited, or when we fear resampling might lead to information loss. In this sense, algorithm level class imbalance strategies appear to recreate the Stoic belief of immersing in the present rather than dwelling on the past or worrying about the future. 5. Anomaly. Detection is called in the situation in which the impact of an outlier is higher than that of other classes. Such situation is addressed through anomaly detection, which can be identified through the following strategies. 1 class SVM, one core value guiding your practice. For example, a highly empathetic person is likely to prioritize interconnectedness and a sense of duty with the risk of becoming sensible to hope. Isolation forest uses the decision tree logic to isolate anomalies till they become fewer and fewer. Ancient Stoics advised towards the practice of premeditatio malorum, imagining difficulties, as a method to train resilience. Premeditatio malorum appears to reflect the isolation forest by detaching the magnitude of a worst case scenario, reminding us that what truly falls in our control are our thoughts, actions, and duties. Local outlier factor implies comparing the density of a cluster to that of its neighbors. Anomalies can be identified through a lower density than that of neighbors. Stoics distinguished positive and negative emotions based on the extent to which such feelings are either rational or unexamined. Therefore, emotions which we haven't reflected upon, of which we have little data, stand out as anomalies. Autoencoders reconstruct normal data, like checking whether an emotion is rational. K-means clustering reflects grounding yourself and staying mission-focused, not lost in ego. 6. Evaluation metrics. In binary classification, true positives are moments we correctly identify our sensitivities. False positives are overestimations of threat. The ROCAUC shows how well we distinguish between them. In Stoic terms, how well do we tell apart what truly matters from what doesn't? 7. Cost-sensitive learning implies assigning higher cost to serious mistakes. Misunderstanding Stoicism as passive resignation has a high cost. It kills growth. Cost-sensitive learning is recommended only when misclassification produces disproportionate consequences. In life, a similar strategy can strengthen our motivation when we want to shed various character traits we recognize as not beneficial to our growth.